Hello everyone. Now let's solve this question. Also using VIETA'S formula. Alright, so the question reads, the real root of the equation x squared plus 6x plus c equals 0 differ by 2n, where n is real and non-zero. Okay, now we want to show that n squared equals to 9 minus c, given that the root also have opposite signs, and also find the set of possible values of n. Okay, so like I said, we're going to use VIETA'S formula, to show why n squared is equals to 9 minus c. Okay, yeah, because n, according to the question, is what? Is real and non-zero. So if n is real and non-zero, so the first thing we need to do is we need to what? We need to find out the sum of roots, okay, and the product of roots using VIETA'S formula. And then, since we are given that the root of this equation differ by what? By 2n, we can now set the absolute value of the difference between the two roots, okay, which we know to be alpha and beta, to be equals to 2n. Then see how we can use that to what? To derive this equation. N squared equals to 9 minus c. Okay, now let's have our solution. Okay, so now we're given the equation x squared plus 6x plus c equals to 0. Okay, now let's alpha and beta, okay, be the roots of the given equation. Let alpha and beta be the root of the given equation. So we know that by VIETA'S formula, okay, by VIETA'S formula, we know that the sum of roots, okay, will be what? Negative b over a. And also the product of root is what? Is c over what? Over a. Now, when we compare, when this equation is compared with the general quadratic equation, that's the general form of writing a quadratic equation. We can say that a equals to 1, b equals to 6, and then c equals to c, okay? All right, so then for the sum of roots, okay, it's going to be negative 6 over 1, and that will be minus 6. And then for the product of roots, it will be c over 1, which will be what? C. Okay, so now, so we have here that the root of this equation differ by 2n. Now, what this means is that the difference between the two roots, okay, that's alpha and beta, okay, is differ by what? By 2n, okay? So that means equals to 2n. So which means now, since the root of the equation, x squared plus 6x plus c equals to 0, okay, differ by 2n. Now we know that the root, that means we're going to have alpha minus beta to be equals to 2n. Okay. Now by squaring both sides, in this case, by squaring both sides, okay, if we square both sides in this case, by squaring both sides, we're going to have, that is the square of difference between alpha and beta, okay, equals to the square of 2n. Okay, the square of 2n. Now, let's obtain the expansion for the square of alpha minus beta. That will be alpha square minus 2 alpha beta plus what? Beta square. And this will be 4n square. Now, we can rewrite this as alpha square plus beta square negative 2 alpha beta equals to 4n square. Now, let's recall from here that, now when we talk about sum of two squares, okay, now we know that for sum of squares, when we write a square plus b square, which is one of the fundamental rules of algebraic, algebra. Okay, we know that alpha, that's a square plus b square, would be a plus b, that's the square of a plus b, negative 2ab, negative 2ab. So which means for alpha square plus beta square, the sum of alpha square and beta square would be alpha plus beta raised to the power of 2. That's square of alpha plus beta, negative 2 alpha, alpha what? Alpha beta. Okay, so now, because we know that alpha plus beta, okay, alpha plus beta is negative 6. Alpha plus beta is negative 6. Now, let me rearrange this equation. Okay, let me rearrange this equation so that we can have square of alpha plus beta on the right hand side. So we can say that alpha square plus beta square plus 2 alpha beta will be equals to the square of alpha plus beta. Okay, now we know that the value of alpha plus beta is what? Negative 6. So we can say that this will be alpha square, okay, alpha square plus beta square plus 2 alpha beta equals to negative 6 raised to the power of 2. And this will be 36. So this is going to be 36. So now, from what we have here, we have this to be equation 1. Yeah, that will be equation 1. Okay. Now we can give this what? This becomes equation 2. Okay. So now, by the time we write this as alpha square plus beta square plus 2 alpha beta, this will be what? 36. And this will be equation 3. Okay, now why I have to, I have this now, this has to be called equation 1 is because now the first equation we need to set up, okay, for this question is the equation, the equation that when the root of this equation, that's the given equation, are alpha and beta, so they differ by 2n, and that's what we have here. That's the first equation. Now the second equation, after squaring both sides, okay, we're going to obtain alpha square plus beta square, okay, negative 2 alpha beta equals to 4n squared. Don't forget that we want to show why n squared is equal to 9 minus c. Okay, so by the time we expand, okay, we expand the difference between alpha and beta, okay, we're going to obtain alpha squared plus beta squared minus 2 alpha beta equals to 4n squared, and that's equation 2. So then also I introduced here that because we have sum of squares to be sum of squares, like what we have here, alpha squared plus beta squared equals to the square of the sum of alpha beta, okay, minus 2 alpha beta. Now, and we have from here that alpha plus beta is what? Negative 6. Okay, so we have minus 6 squared, which is what? 36. And that is what we have as equation 3. Now, so what we're going to do now is we can subtract, okay, we can say subtracting equation 2, okay, subtracting equation 2 from equation 3, okay, from equation 3. Now, we know that equation 3, this is equation 3, that is alpha square plus beta square plus 2 alpha beta, okay, minus equation 2, that is alpha square plus beta square minus 2 alpha beta. Then we can now have, because we are subtracting equation 2 from equation 3, so that will be 36 minus, that will be equals to 36 minus 4n squared. So we have this. So now let's remove the parentheses, using distributive property. So by removing the parentheses, we're going to have, so what we have is alpha square plus beta square plus 2 alpha beta. Okay, removing the parentheses, in this case, this will be negative alpha square, and also what? Minus beta square, then plus 2 alpha beta, okay, and this is what? 36 minus 4n square. So alpha square minus alpha square, that will be 0. Now beta square minus beta square, that will be 0 as well. Now here we have 2 alpha beta plus 2 alpha beta, that will be 4 alpha beta, okay, and this is equals to 36 minus 4n squared. Okay, now let's recall from from here that we have the product of alpha and beta is equals to what? C. Now, so let's recall, we know that alpha beta is what? Is C. So which means this equation will be, this equation will be 4C equals to 36 minus 4n squared. So we can now divide the equation by 4 because 4, okay, we can divide the equation by 4 because 4 is a factor of 36 and it's also a factor of itself. So divide both sides by 4. So we can then have 4c over 4 equals to 36 divided by 4, then 4n squared over 4. So that c will be equals to, this will be 9 negative n squared. Now we can rearrange the equation so that we can have what we have. That's what we have, this equation. So that this will be, when we rearrange the equation, this will be n squared, okay, equals to 9 minus c. Okay, so we just show that n squared, okay, equals to 9 minus c because n is real and non-zero. So this is proven. We have this proven. Okay. Now the second question, okay, further we have, given that the roots also have opposite signs, find the set of possible values of n. So to find the set of possible values of n, we need to understand that now the fact that the product of roots, which is alpha beta, is equals to c. So it means c will be less than 0 because c is a non-zero number. Okay. Now, so we have, let me call this Roman numeral 2. Okay. So the roots also have opposite signs. So since the roots, okay, have opposite signs, since they have opposite signs, okay, so which it means that the product of alpha beta, okay, will be equals to c. Therefore c, okay, therefore c will be less than 0 because c is a non-zero number. Okay, it is real and non-zero number. So because c is a non-zero number, so we then have n squared to be what? To be greater than 9, because we want to what? We want to find the set of possible values of n. Okay, to find the set of possible values of n, they have opposite signs. So if they have opposite signs, so we're going to what? We're going to use inequality. Okay, we can also use equality. Okay, but the condition here is that when c is less than 0, then the square of n will be greater than what? 9. Okay, so we then need to obtain the two possible values for letter n. All right, so in this case, if we square both sides, we are going to have plus or minus the square root of 9. Okay, so which means in this case we are going to have n to be greater than 3 or n to be what? To be less than 3. Okay, now we know what to do from here, just like the way we now when we write this as equality symbol instead of inequality as we have it here. But like I said, the condition here is that since the roots have opposite signs, and we know that the product of root is equals to what? C. Okay, and from what we show here, we have n squared equals to 9 minus c, where n is a non-zero number. Okay, so it means that n squared will be greater than 9. Okay, now because c is less than 0, okay, that's why we have our n squared to be greater than 9, and also one of the values of n, okay, will be -3. So which means if you are going to set the values of n, so the set of, so in this case we can say the set of possible values of n, okay, would be, we're going to have -infinity, okay, -3 union negative what? Now positive infinity and what? And 3. So this will be the set of possible values of n that's for the second question. The noblest pleasure is the joy of understanding. Bye bye.